All right, lesson 7. Again, last one before the quiz. Quiz will be over 1 through 7 with the exception of 6, something that's not important in my opinion, residuals. So the correlation coefficient. The whole point of a correlation coefficient, usually abbreviated with the letter R on Desmos or any graphing calculator, and it will tell you how good your data is. Okay, it will tell you how good your data is. Now, a couple things before we jump into it. It will always be between -1 and +1. The R value will always be between those two numbers. Negative means just that it's sloping just like the slope is. It would be going downhill. If the line goes downhill, your R value will be negative. If your line goes uphill like this one, your R value will be positive.
Why can't it be like...
The closer it is to 0, very bad data. Absolutely scattered all over the place if it's close to 0. The closer it is to 1 or -1, awesome data. Question, Georgia?
-1's good.
Yep. It's just the opposite direction. Yep.
This means it's going down.
So -1 or 1. Good point, same thing. So looking at those 4, which one doesn't belong? B? Why?
All over the place.
Yeah, all over the
Maybe one
place.
direction.
All over the place. I do like A. You know, seems like a strong linear value. I'm guessing that one would be fairly close to 1. This one's probably fairly close to -1. This one, I don't think a line would be so good, but it is, you know, it's certainly curved. That'd be more of an exponential growth, which we'll get to. Which one do you think is the best out of A or C? Which one would have the dots line up the best?
Okay.
So I would guess that one would be the R value closest to 1. All right, the next example, we're just going to look at some different graphs here. And I would just like some ideas on how you think we could sort them. If we were to put them in categories, how could we do so? So I'll just show you a couple groups of them here. There's a set. Here's a set. So these graphs are any graph. How are some ways you could categorize them? Let's say in 2 groups. What are some things that you could group any graph, any
Linear
content?
or good and bad.
Good and bad? A little more detail.
Well, no, like...
What do you mean by-
If it's closer to the line or if it's scattered everywhere.
Okay, so more linear
Negative or positive?
and then really scattered. Okay, that's a good way to sort them. Amy, what'd you mention?
Negative or positive?
Negative slope. Positive slope. Anybody have another way that we could sort any graph besides those 2?
If it's steep, does it count? Like it's steep.
Where at the greatest
Steepness, sure.
great, high y-intercept and low y-intercept.
Again, looking at the slopes, is it a steep line or flat? What'd you say, Mara? That was yours? What was yours, Georgia?
If the y-intercept.
By y-intercepts? Like positive or negative? Okay.
Well, no, they're all
That's 4 different ways. That's plenty of ways you could sort them. And there'll be benefits, pros and cons to each. All right, the next one I want you to do alone, and then you're gonna compare with somebody. It gives us 8 graphs, and it gives us 8 correlation coefficients, 8 R values. So I would like you to see if you can match up those 8 letters with the R values. Remember what we just talked about, how the R value correlates. Once you think you have all 8, please compare with somebody close to you. I will give you a few minutes to try that. So you're gonna match those 8 numbers with the 8 graphs. Alan Jordan? Go? Compare with somebody? Hop in with that group. Connor, you done? You already went?
Yeah.
Agreed?
We have the
Exact same. Timbo?
I'm waiting for Caleb.
Caleb? Close?
Yeah. Me and Tim agreed. Or Tim and I agreed.
Close, ladies? We have similar answers?
Me too.
this one?
I didn't look at them.
It's supposed to go on the
So
left side.
if that's the other side.
What does it mean, just like?
So you don't get.
I kind of went over from like best to common and then best. Okay, so it's negative slope and it's really close to that.
Do you get any other pins?
Really close to it.
Like, is there any other type of pins? that
No,
you can-
every sport will have something like that. So if you're in baseball, you'll get a baseball pin, and then the same thing, or whatever.
I'm not in baseball.
No.
Okay, and then that's.
Then if you're like me, Caleb, it eventually gets so heavy you put on your jacket.
Back. So that would make.
What, because you're a super senior?
Yeah, well, it's all through high school, right? All right. So the answers are on there. Hopefully, those little hints helped you at the beginning of the lesson. R values are not difficult, but it does tell you how good your data is. And we're going to do one more example of that with the Are You Ready? Jada wants to know if the speed that people walk is correlated with their texting speed. So as the faster you walk, the faster you text or you can text, or slower, and so on. She measured the distance in feet that 5 of her friends walked in 30 seconds and how many characters they texted during that time. Each of the 5 friends took 4 walks for a total of 20 walks, and here are the results. Okay, so they are listed there. So please go into Desmos, put it into a table, X and Y. They got to be together, so I would do all the X's first, and then all the Y's.
There's 2 tables?
There's, well, this one first.
I don't understand.
This is one
Who wants
table.
to do one side at a time?
Yes.
Huh?
No, this is all one table. There's another table that we're gonna make over here to compare them. This is one table.
But should I
Make
go-
one table. X's, Y's. One table.
Good.
How do you add more X's and Y's?
You just hit enter and they keep getting further. Plus sign table.
So it would be X1 still and then
Yep.
it just says air.
Yeah, I want one table. You just go down, Georgia. You take the numbers down.
That's how it looks like later.
Take the numbers down.
Even
105,
with
enter. 125, enter. 115, enter.
Like that.
Straight down. This.
Oh, then when it gets to the other X, you just keep
Keep
going.
going. Anybody have it?
Yeah.
Samantha got it?
Do you want us to make the equation?
We'll just have the dots for now. All right, so here's what I would like you to do next, once you have those, and there are quite a few of them, right? So I'm just assuming Samantha's got them all correct here. Hit that little, did you hit that plus sign?
The magnifying?
The magnifying glass thing? All right. So I'm kind of showing you both here at the same time. The one on the right is a different set of data. Instead of putting them into a table, they showed you the dots. So we're going to answer some questions on the next page. They have a different set of table here. So that is the same one that we have. This is actually the second set of data. So can you look at both of those at the same time?
I have a question.
Data set 1, data set 2. Yes.
How do we find
Correlation coefficient?
the correlation coefficient on Desmos?
I'll show you.
Okay.
Same thing we typed in last week, it does tell
Is
you.
it gonna be like tons of numbers?
Yeah, a couple decimal points is fine. Remember, you just care how close it is to 1. All right, it says, what do you notice about the two scattered plots? So the one that we did, the second one on page 87, what do you notice? Anything stand out?
Wait, 87? Oh, yeah. The first one's better.
Which one traveled further?
First one.
Which one goes further to the right? Now look at the scales.
Second.
The one on 87.
One on 87. This one almost goes to 250 feet. Our last one's about 160. So this one travels further. I would write that down. Second group traveled further. Traveled more distance. Can we say anything about texting?
They also texted more?
They also texted more, got more characters in. I'd mention that as well. So traveled a further distance and got more characters in. Question number 2. Jada noticed that her friends walked further and texted faster the last 20 walks than they did the first 20. Since both were faster, she predicts that the correlation coefficient of the line of best fit for the last 20 walks will be closer to -1. Do you agree? Do you agree that this one will be closer to -1 than this one?
No.
Why not?
No.
I disagree as well. What?
Well, the one that we made on our iPads looks like they'd be more on the line if it were.
Yeah, exactly right. This one looks like it's more linear than this one. So exactly right. Data set 1 appears more linear, is how I would answer that. I disagree with Jada, because data set 1 appears more linear. Okay, now to get the correlation coefficient, I will tell you the second one. You don't have to type those in again. The equation I said you must have written down to help you with the homework. Y. 1. Tilde. A. X. 1 plus B.
Is that what you're talking about, or should I have written down?
That's what you need to have written down, because every one of these you'll have to have that.
I took a screenshot.
All right, so your slope. Here's your slope and your y-intercept. So if you wanted the equation, it would be negative 0.85x plus 218. If you wanted the equation, which the homework today did twice. two different ones. But right now, what I'm concerned about is this value. How would you classify our data? So our R value, Georgia, you said it'd be a long number. It is. I'm gonna round it to negative 0.95. How would you classify that? I don't care about R squared. We'll talk about that another time. Just R.
0.95.
You good with that?
Negative 0.95.
Is that pretty good?
Yeah.
Yeah. And you can see on our graph that it's pretty good. Hits quite a few of them, about the same number above and below. Go ahead, Georgia.
Sorry, I was typing the equation and you were talking, but what does the R squared have to do?
We are not worrying about the R squared.
Okay.
Okay, so data set 1, let's just write the equation. Negative 0.85x plus 218.61. R value, negative 0.95. That was graph 1. Graph 2. Again, I could have you type all those in again, but they're all the same, so I'm not going to do that. I will give it to you. Here is just the R value, that's what we're comparing. You said it was going to be worse. The R value is negative 0.68. Again, negative because it's going to go downhill. And as you mentioned, 1 was going to be better, and it's quite a bit better. So our previous answer was correct to answer number 3. So if you had to answer 4, why do you think the R values are so different? Again, we've answered this a lot. First one, the dots are more lined up. B, they're not as much, they're more scattered. And that all deals with the correlation coefficient, the R value. More examples on page 88 for you. Shows you a bunch of scattered plots based on their R value as well are listed on the bottom. So that is a good reference for you. Remember that number is called the correlation coefficient. Correlation coefficient, page 88. Okay, your homework. I make a line again for number 4. Does go on to the next page. Question number 5, I'm going to change that. Remember, we did not talk about residuals. So I would just like the equation and the correlation coefficient for that data. That's all I want for that, using Desmos. Don't worry about these. All can be crossed out below that. And 6, I'm going to let you skip that one. That's again talking about residuals. We haven't done it. So just the first 5, cross out 6 as well. So remember, tomorrow we will have a quiz over 1 through 7 before Thanksgiving break.